Hello everyone. Here are the solutions to the assignment I gave you guys on Tuesday that was 1 through 10. Later on in the day I will post the solutions with the work so you can definitely check. But for right now, just check these solutions, go back and retry the problems if you didn't get these answers. Remember to rationalize your denominators and simplify as far as possible. And as always, email me if you have questions on any of these. So that worksheet that I gave you guys on Tuesday, we're going to continue to do some slightly different equations as examples that will help you get through some more problems off of that worksheet. So our goal for today is still to solve equations involving radicals. So please get out a sheet of paper. These are the steps involved when we have a variable that's underneath the radical or in the radicand. So again, a radical equation is one in which there is a variable that's underneath the radical. In order to solve this type of an equation, we want to isolate the radical, get everything, kind of like with absolute value, we want to get everything that's outside of the radical that's on the same side over to the other side. We want to isolate the radical. Then we want to raise each side to a power equal to the index. So if it's a square root, we want to square both sides. If it's a cube root, we want to cube both sides. If it's a fourth root, we want to raise both sides to the fourth power. Then we continue to solve for the variable. And this very last step is very important. We need to check our solutions. Sometimes we're going to get what we call extraneous solutions, extra answers that do not satisfy the equation. So always check solutions, just like with absolute value equations. All right, pause the video if you still need to copy that down. We are going to move on to our examples. All right, so just take a look at only number one. If you notice, we have a variable underneath the radical. Go ahead and copy that down. So our first step, the radical is already isolated. There's no numbers outside of it that's over here on the same side. So what we want to do, I'm just going to rewrite the problem. We want to get rid of the radical now. So we want to square both sides. And no matter what I square, I always like to put it in parentheses, because if it's a binomial, it's going to make a big difference. So what we're going to have left over here on the left side, the square root and square are inverses, so they cancel each other out. We just have a 3x plus 1 is going to equal 16. And then we continue to solve for x. Subtract 1, so 3x equals 15. And then x is going to equal 5. Now this is a pretty simple one to check. I'm going to do this off to the side here. If I have the square root, 3 times 5 is 15, plus 1 is 16. Now notice this is just the positive square root of 16 is going to equal a positive 4. So we have 4 is equal to 4, so we know that that is the solution. Go ahead and copy down number 2. Notice here, though, this is the cube root. But again, we want to first start this problem off by isolating this. So we have a minus 2 over here. Let's just get rid of that, take it to the other side. So now this becomes the cube root of n plus 1, which is equal to 2. Now to get rid of a cube root, we are going to cube both sides. So now we're just left with n plus 1. 2 cubed is 8. Subtract the 1, n is 7. Let's check our solution. We're going to get the cubed root of 7 plus 1 minus 2. We want to know if that's going to equal 0. So we get the cubed root of 8 minus 2 is equal to 0. The cubed root of 8 is 2. 2 minus 2 is equal to 0. So we have our solution. All right, let's take a look at number 3. Just like our last problem, we want to isolate our radical. Notice we have a square root here. So I want to start by subtracting 7. So we're going to have the square root of x minus 3 is going to equal a negative 6. Now right here, it's a little bit of a warning sign. We have a positive square root, much like an absolute value is always positive. We have a positive square root is equal to a negative number, and that's never going to happen. But even if we didn't catch that, let's continue to solve. So I want to square both sides. So this will give me x minus 3 is going to equal a positive 36. And then if I add 3, I'm going to get x is equal to a positive 39. But this is why we check our solutions. Because now I'm going to take 7 plus the square root of 39 minus 3. I want to see if that is equal to 1. So I get 7 plus the square root of 36 is equal to 1. This gives me 7 plus 6. Clearly that is not equal to 1. So even though I got an answer, it did not satisfy our equation. So we would say no solution. Or if you caught this step up here, we could have recognized that and said, well, that's never true. And then we go straight to no solution. Let's take a look at number 4. All right, now here we have two radicals technically, but we only have a variable underneath one of them. So this radical 21, even though there's a radical, it's just a number. So what I'm going to do is, just like all the others, we can move the radical 21 to the other side. And I want to do it this way on purpose. Now it's going to become a negative radical 21. My radical over here still isn't by itself. There's really a negative 1 out in front. So I could divide both sides by negative 1, and it gets rid of the negative. So then we have the square root of 5x minus 4 is going to equal a positive radical 21. We would have gotten that way too if we left the radical 21 over here and just took the radical, added the radical 5x minus 4 to both sides. It's just on the other side. Now at this point I want to get rid of the square root, so I'm going to square both sides. So I'm going to have 5x minus 4 is just going to equal 21. And then we'll add 4. So 5x is going to equal 25. Divide by 5. So x is going to equal 5. We still want to check. Always check. Square root of 21 minus the square root. 5 times x is 5 times 5. So that's 25 minus 4. I want to know if that's going to equal 0. So we get the square root of 21 minus square root of 21 equals 0. And yes, radical 21 minus itself is 0. So there's our answer. All right, go ahead and copy down number 5. So two things we need to get rid of first. If you notice, we're subtracting a 3, so let's add 3 to both sides. So we still have 2 times the square root of r plus 9. This is going to equal 10. Then we have to get rid of that 2, much like we got rid of that negative 1 that was in front of our radical in the last problem. So now we're going to just divide both sides by 2. So the square root of r plus 9 is going to equal 5. And now we want to do what, guys? Hopefully you're thinking square both sides. Yes. So here we get r plus 9 is going to equal 25. And we simply subtract 9. And we get r is equal to 16. And again, let's just check this. So we're going to get 2 times the square root of 16 plus 9 minus 3. Again, we want to know if that's 7. We get 2 times the square root of 25 minus 3 is 7. This becomes 2 times 5, which is 10. So we can just jump straight to that. 10 minus 3 is 7. So that is our solution. Okay, just a couple more examples to get through. These problems are going to start to change in our next example. Go ahead and copy down number 6. If you notice here, we have an extra variable that's not underneath a radical. So this is where it's going to change. Right now, on the left side, we have our radical isolated. So our first step is to square both sides. But notice over here, it's a binomial, so I need to square that binomial. So now this becomes x squared minus 8 on the left. To help us make the least amount of mistakes. I'm going to go ahead and just write this out side by side. So we're going to get x squared minus 8. Over here, we're going to get x squared. On the outside, we're going to get a minus 4x. On the inside, we're going to get a minus 4x, and then plus 16. So we get x squared minus 8 is equal to x squared minus 8x plus 16. Now, right now, yes, this right side is quadratic, but if you notice, we have a quadratic term over here, and aren't they both the same? So if I were to subtract x squared from both sides, they're just gone. So now I have a negative 8 equals negative 8x plus 16, and I still just use inverse operations to get x by itself. So let's go ahead and subtract 16 from both sides. That'll give me a negative 24 over here equals negative 8x. Divide both sides by negative 8, and x should equal 3. But let's check this. So if I have the square root, 3 squared is 9 minus 8. Over here, I'm going to get a 3 minus 4. Square root of 9 minus 8, that's square root of 1, is equal to negative 1. This is the positive square root of 1, so my left side is just going to give me a positive 1. That's not equal to a negative 1. So even though it looked good, this is a positive square root. So this expression over here has to be positive. And when x is 3, it's definitely not positive. So I go back, I cross that out, and I really have no solution. Another nice way to check, too, is on Desmos, if you were to graph the square root of x squared minus 8 as one function, then you graph the line y equals x minus 4, they're never going to intersect. All right, let's try one more. All right, now with this, again, we want to follow those steps. We want to isolate our radical, so that's the square root of 9x squared minus 20. I'm going to add 3x to both sides, so it's really a negative 2 plus 3x. I'm actually going to flip this around. Square root of 9x squared minus 20. And no, I can't simplify anything underneath because it's not, there's a minus sign here. I'm not multiplying the 9x squared by the 20. So over here, I just mean I'm going to rewrite it as 3x minus 2. So when I go to do my next step, which is to square both sides, again, the 3x minus 2 is one quantity here that I need to square. Now this will become 9x squared minus 20. Again, I want to write this out side by side so I don't forget the inside and outside terms. So we're going to get 9x squared minus 20. This will give me a 9x squared. On the outside, we'll get a minus 6x. On the inside, we'll get a minus 6x and then a plus 4. Now, like the last problem, look at the quadratic terms. 9x squared and 9x squared. They're the same. So if I subtracted 9x squared from both sides, they're gone. Now I have a negative 20. I'll get a negative 12x plus 4. I want to subtract 4 from both sides, so we'll get a negative 24 equals negative 12x. Divide both sides by negative 12, and x equals 2. But as you know, we have to check this. So as I go to write this in, that's 9 times 2 squared. 9 times 4 is 36 minus 20 minus 3 times 2. That should equal a negative 2. So I'm going to get the square root of 16 minus 6 is equal to negative 2. That's 4 minus 6 does equal negative 2. So we get to keep that answer. All right, so these examples now allow us to continue on that worksheet that I gave you guys Tuesday. Please just do 11 through 20. Make sure you do all your work on a separate sheet of paper. As I mentioned at the beginning of this video lesson, the answers to 1 through 10, the solutions with work, will be posted a little bit later today. So once that posts, please make sure part of your homework tonight is to go back over and view those solutions so you guys know how to do these problems. And always let me know if you have any questions.